Today, my plan is to cover the integral of the form integral, tangent, and secant. And next, we're going to move to trigonometric substitution, which is the hardest one for this chapter. All right. We're going to start by looking at integral of the form tan to the m power multiply secant to the n power. On the slide here, I have integral of the form the product of power of tan and power of secant. So the idea is the same as before. So when we do integral of cosine to the m x and sine to the n x dx, this is what we did last week. I told you that you have to first trying to pick u equal to sine. Second, try to pick u equal to cosine. If both do not work, you can just use the identity, right? Because it's going to be like even power, and then you can use identity. The same thing with tangent and secant. So when you look at the problems, you're going to have three choices. So the first one is you pick u equal to tangent. The second one, you can pick u equal to secant. The third one, if number one and number two do not work, you can try to use integration by parts. So we're going to show you some examples. Well, first of all, keep in mind that when you differentiate tangent, so you get secant square x dx. And if you differentiate secant, so you're going to get secant and tangent multiply together dx. This is going to be your skill form before midterm that you need. And another one is when you have cosine square x plus sine square x equal to 1. If you divided everything by cosine, so you're going to get 1 plus tangent equal to secant. Does it make sense? So this is how I memorize 1 plus tangent square equal to secant square. This is going to be the identity that you're going to use a lot on this section. 1 plus tangent square equal to secant square. All right, let's look at real examples. You ready? All right, so example 161, I want you to evaluate integral of tangent to the 6th power times secant to the 4th power. Well, first of all, when I see tangent multiply secant, well, I can list that. Well, I have three ways to do it. First, you pick u equal to tan. Second, you pick u equal to sec. 3, I can use integration by parts if the first two do not work. So I'm gonna pick u equal to tangent first. Well, if I pick u equal to tangent, I'm gonna get du equal to secant square x dx, right? And then let's do substitution. So I'm gonna get integrate tan to this. Oh, well, tan is u now, so it's gonna be u to the 6th power times secant to the 4th power x, and then du over secant square x. Well, from here, I'm gonna get the x equal to du over secant square x. Well, you can see that I just replace the x by du over secant square x. And then after that, I can cancel two factor of secant. So I'm gonna get integrate u to the 6th times just secant square x dx. So your idea is you're trying to convert everything to u. Here you have secant square x. But luckily, as I told you that, hey, when you see secant square x, you can convert to tangent. Well, if you are like me, I do not know how to memorize that thing. I have a hard time to memorize secant and tangent formula. So I'm gonna start by cosine plus sine equal to 1. And every time I am going to do is, I am going to divide everything by cosine square. So I have 1 plus tangent equal to secant square. This is the best way to memorize, in my opinion. So I'm going to say this is u to the 6th power times 1 plus tangent square x du. Well, but I know that tangent square is u, right? So this is tangent square is u square. So this is u square du. Well, I'm going to get integrate u to the 6 plus u to the 8 du. So which is going to be u to the 7 over 7 plus u to the 9 over 9 plus c du. I can replace u by tangent. Basically, this is nothing more than u substitution. This is nothing more than the content before midterm. So you should be able to do this thing easily. Does it make sense? All right, this is like a warm up for today. So you just need to integrate this thing by using u substitution. All right, so let's move to example 162. All right, now I want you to integrate tan and secant, but the product that I have is tangent cube times secant to the 7th power. I'm gonna first choose u equal to tangent. Well, that is going to be my first guess. So I have integrate tangent cube secant to the 7, and then I pick that u to be tangent. So I have du equal to secant square x dx. So I can switch my dx to du over secant square x. And then you can see that I can cancel 2 factor of secant. So I'm going to get just secant to the 5th power. Well, my tangent is u, so I'm going to get u to the 3rd power and then secant to the 5th power x du. You can see that I got stuck here because I have secant to the 5th power, and this is not the even power. So what I have in my hand is secant square x equal to 1 plus tangent square x. I cannot convert secant to the 5th power to tangent because this is, this is the odd power here. Well, that means this u does not work. So you have to redo it. Well, if the first one does not work, well, don't give up. So you still have the remaining 2 ways to do it. So we're going to let u to be secant, and hopefully it's work this time. So it's going to be integrate tan cube secant to the 7th power x, and then because I picked secant to be u to be sec x, so I'm going to have du equal to secant tangent x dx, which is pretty easy, right? Because the x is going to be just du over secant and tangent. So that means 1 factor of tangent and 1 factor of secant gonna cancel out, which make us happy because, well, I can cancel that 1 tangent. I can cancel that 1 secant. Looks good to me because at the end I have all the even power, which is good. So it's going to be integrate tangent square, and then secant is u. Well, tangent square is what? If you are like me, so hard to memorize, but I have secant square equal to 1 plus tangent square x. Well, which means tangent square, this is secant square x minus 1 times u to the 6 du. Well, if you replace secant by u, so this is u square minus 1 times u to the 6 du, which is u to the 8 minus u to the 6 du. Right? Does it make sense? This is pretty simple, right? And then after that, you integrate that, so you get u to the 9 over 9 minus u to the 7 over 7 plus c. just secant to the 9 power x over 9 plus secant to the second, 7 power to over 7 plus c. All right. Well, as I told you, if you feel like, Ajahn, why is it so easy? Well, as I told you, this is just the U substitution. Okay, minus sign. Thank you. Who said that? Puri? Yes, minus sign. All right. So let's climb to the next one because we're gonna just increase, the difficulty. Integrate 10 to the 4th power x dx. So what should we do? All right. First of all, I'm gonna just trying to pick u equal to tangent and see how it's work. Well, my du gonna be secant square x dx, right? Well, which means I can say this is 10 to the 4th power. Well, dx gonna be du over secant square x. Are you going to continue this thing? Well, if it were me, no, because I have secant square here. I have tangent to the 4th over here. Well, they do not cancel. Well, this will not work for me. Bye. So I'm gonna just do u equal to secant, and that is secant tangent. Someone gonna say, hey, Ajahn, we have the same problem, because if you do this, you're gonna have 10 to the 4th power, and the x gonna be du over sec x dx. Again, well, I have secant here. Well, we are going to have this problem all the time, right? Because if you integrate tan to some power x dx, even you use u equal to sec x or u equal to tan x, you're going to have sec here for sure on the denominator. Because differentiate tan, you get secant square. Differentiate sec, you get sec tan. So the idea is, well, I told you that this third method is using integration by parts. But before using integration by parts, well, you can think that because you have the identity that you can switch between tan square and secant square, what if I split 10 to the 4th power to tan square 2 times? The reason why I do this is because if I split 10 to the 4th power to tan square 2 times, so the idea is I am going to replace my tan square x here by secant. Well, I know that secant square x, this is 1 plus 10, right? 10 square x. Well, if I replace tan square x by secant square x minus 1 dx, this would work. And then this is going to be integrate tan square x sec square x dx minus integrate tan square x. Does it make sense? So the idea for this question is we use the identity sec square x equal to 1 plus tan square x to reduce the power of tan. Why is it important? It is important because we would love to see secant to the mx, right? We want to see secant to the mx because if you have secant here, when you do u substitution, you can cancel out your secant, right? Because even you differentiate tan or secant, well, no matter what, you're gonna have secant equipped with you, right? Differentiate secant, you get secant tangent. Differentiate tan, you get secant square. So sometimes you need to reduce the power of 10 by using identities. This is the example. So you can just reduce 10 to the fourth power to 10 squared 2 times. And one time you just change it to that. Well, another time is you can see, hey, Ajahn, we have 10 square again. Well, because if you pick u to be tangent or secant here, it will not work because you're going to have something in the denominator with secant again. So that means the best way to do that, to deal with that term, is you switch another 10 square here to secant. Well, because we love to see secant. Secant is the easy one to integrate because we have the formula of integrate secant square x, right? This is going to be integrate 10 square x secant square x dx minus integrate secant square x plus integrate 1 dx. Oops, I missed one thing. All right, dx here. All right, good. Now I can continue my work. This is going to be integrate 10 square x secant square x. Well, I go pretty fast here, so I'm going to pick the 10x here because I pick u equal to 10, so I have secant square x here. So something going to cancel. Good. So the second term I integrate that thing, so I'm going to just save it for later because I know how to integrate secant already. Secant square, because this is just basically just tangent and also 1. This is easy to integrate. So everything is ready to integrate, right? So I get 10 cube x over 3, right? Because this is integrate u square du, so I get u cube over 3, and then plus integrate secant square, I get 10x, and then integrate 1, I get x, and then do not forget to plus c. Sounds good? Well, this is why integration technique is so hard. Each question you're gonna have different technique, and you're gonna gain this thing by just doing examples and practice problems. That's no perfect formula for you. Well, you have to gain experience by doing more and more and more and more problems. This is why this chapter is supposed to be the hardest one for final exam, because this is so tricky. All right, so let's look at example 164. This is going to be the last one for secant and tangent, which is going to be the hardest one for this technique as well. Sounds good? Well, any questions so far? On the chat, please, if you have any questions. All right, sounds good. If not, we're gonna go to 164. I'm gonna show you something here, something that is interesting. So integrate 10 square times secant x dx. So first of all, you can see that, well, I'm gonna go a little bit faster compared to the first 10 minutes. Let's suppose that you wanna say, hey, this is, I pick u equal to 10. So I have secant square x here. Can you continue this thing? Well, you can cancel 1 sec. And then you have that thing. Do you want to continue this thing? For me, no. Well, you have 10 here. You have 10 here, which is good, but you need to convert sec to 10. No way. I'm not going to do this. So the second one, if I say, hey, Ajahn, now I do d sec. Whoa, this looks good, right? Sec x, tan x. Damn it. Sec cancel. Tan cancel 1 time. So you get tan x. Well, at the end, you get integrate tan x, d sec x. How would you go on the next step? Secant here, you have to convert tan to sec. This is just tan with degree 1. No. No way you can do it. Well, you can see I picked tan and sec, and both of them do not work. What should I do now? So the the guideline say, hey, by parts. How could I do by parts here? Well, first of all, I am going to reduce tan square to sec. This is the same technique with the previous question. Because we love to see sec to the mx, so we're going to use the identity to reduce tangent to secant. This is typically a good recommendation for you. When you feel like, hey, I have no way, I cannot pick u equal to sec, I cannot pick u equal to tan. My first suggestion is, let's try to convert tan, the power of tan to secant first. Because if you end up with the secant raised to the something, you can bypass. So we're gonna do this as your example. So we're gonna reduce this to, well, tan square is secant square x minus 1 times secant x dx. And then now I am going to expand it. So I got sec cube x dx minus integrate sec dx, sec x dx. Well, you have formula for this thing. This is good. Well, but this is not good because you don't have formula for sec cube. But just integrate sec here. Keep in mind that from chapter 4, when we learn transcendental function, we just say that integrate sec x dx. This is log sec x plus tan x plus c. So that means I can deal with this thing easily, the second term here. Well, I'm happy with that. The only thing that I need to be worried now is the first term. How can I integrate sec cube? Well, by parts. All right, integrate sec. Gonna show you integrate sec cube x dx. Well, something to keep in mind if you want to memorize. Integrate sec to the something x dx. Well, if this thing is an odd power, you have to bypass. No other ways you can do it. You have to use integration by part. Even you try use substitution or something, if you see integrate sec cube, sec to the 5th power, sec to the 9th power, sec to the 11th power, sec to the 25th power, well, you have to bypass. You have no other way. Well, you can memorize it. This is just a trick. So now I'm gonna pick, well, I have to integrate secant square, secant cube x dx. So I'm gonna pick u equal to something, dv equal to something. So I need to pick dv to be something that is easy to integrate. So I'm gonna split sec square here. Gonna leave one sec here. And then now I can differentiate sec. I get sec tan. And then v here get integrate sec square. Well, the reason why I do this because you can see that I split secant cube to sec and sec square because I know how to integrate sec square. And it has a good form, tangent. If you leave dv to be just sec x dx, well, you can integrate as well, but you're gonna get log sec bok tan, which is hard to deal with. So I'm gonna just pick something like this. And then integration by parts gonna give you something good. Let's see here. So you're gonna get u times v minus integrate v and then du. All right, and that means I have sec x tan x minus integrate tan square x sec x dx. Ajahn, this is come back to the original question, right? This is the same thing with the original question. Well, that means this is good because this is going to be your this phase, right? If you go back to that, I have this thing. 1 second, everyone here. And after I use integration by parts, this term, this is from integration by parts, and then minus sec x dx. Well, you can see that, hey, I can group the left hand side to be 2 times integrate tan square x sec x dx. And then on the right hand side, I have sec x tan x. Well, integrate sec, I get log sec x plus tan x plus c. And then I divided everything by 2. Right? Oh, I'll go slower than that because some of you don't like when I skip step. So I'm gonna just that so I can whoops go. All right, so I can divided everything by 2, right, everyone? So this is going to be 1/2 CO2 is just C, right? Just constant. All right, this is our answer. All right, sounds good. All right, any questions? Well, yeah, that's have question. Why C? Well, actually C has to divide it by 2, but is it just arbitrary constant? So I can drop. Well, you can leave the answer here. Well, I can say, hey, this is another constant C, the big one C. Right. Well, you can say this is C1, and that is C1 over 2, which is C. It's, yeah, it's just the arbitrary constant. Make sense? All right. Any question, everyone? Well, we have learned 3 techniques, which is integration by parts, partial fraction, and trigonometric integrals. So the last one for this chapter and the last one for today is trigonometric substitution. Do we have to add C when integrating by U? I have a question from Pimapon. Do we have to add C when integrating by U? What do you mean? So when you integrate, you need to add C because this is your indefinite integral. You have to add C no matter what. You have integrate with respect to U or integrate with respect to X. You have to add some constant. All right, so let's look at the last technique. So keep in mind that this is the hardest one for this chapter, and supposed to be the hardest one after midterm as well. We're gonna look at trigonometric substitution. So the hard part of this thing, this is because the problem is so long. For each question is gonna be long, very, very long for you because you have the technique is, well, let me show you the idea. So the idea is you're gonna do a substitution. Once you do a substitution, so you're gonna do integration. Well, I would say trigonometric integration. On variable theta. Well, which you have to do 2 steps, which is hard. Well, you have to pick the substitution first, and then after that, it's going to reduce you to some trigonometric functions. And then after that, you have to integrate on that new variables. So let's illustrate the situation by looking at example. But before looking at the next example, so we're going to show you one case here. Well, if you have a square minus x square in your integrand, so everyone stay with me. So, and think, if you have a square minus x square, well, the suggestions say that if you have a square minus x square, you're going to pick x equal to a times sine theta. Well, if you pick x equal to a times sine theta, what happened? So if you pick x equal to a times sine theta, so a minus x square gonna be a square minus a sine theta square. And then you can expand the square, so you get a square minus a square sine square theta. And then after that, you pull out a square here. So you're going to get a square times 1 minus sine square. And then you get a square times cosine square. That means you can reduce or change to another form. Change a square minus x square to another form in terms of theta. And then you're going to integrate with respect to theta. Because you know how to integrate trigonometric functions. Does it make sense? Well, if it does not make sense, let's look at example. So 165, so you can see, hey, I have this. Well, the idea is every time when you see 1 minus x squared here, I should say every time when you see a square minus x squared, you can do a substitution by let x equal to sine theta. Right? What's the question say? Oh, a to x equal to a times sine theta. When you do that, it's guaranteed that your integral here gonna reduce to something in terms of theta, and then you integrate with respect to that theta. Well, let's try it. All right, this is your first example on trigonometric substitution. So I'm gonna go slowly. All right, so we're gonna, well, because we have 1 minus x squared, so we pick x equal to a times sine theta. Your a is 1. So we're going to pick just x equal to sine theta. All right, how do I know that a equal to 1? So this is a squared minus x squared. This is your a. Right, this is your x. Sounds good? All right, once you pick x equal to sine theta, so let x equal to sine theta. Well, integrate x cubed over 1 minus x squared square root dx here. Well, your idea is you're gonna convert everything into theta. All right, x is sine theta. All right, keep going. This is sine theta. Dx must be something in terms of theta. So we're gonna differentiate x with respect to theta. So differentiate sine, you get cosine. So dx, well, you have to convert to cosine theta d theta. Sounds good? Now, everything just turn to something in terms of theta. All right. So integrate sine cube. Well, on the denominator, I have 1 minus sine square. So I get cosine square. And that cosine theta times d theta. And then here, look at this sine cube theta, right? Well, integrate cosine square. Do you get cosine square? Oh, actually, you need to get absolute, right? Absolute cosine square. To avoid the problem about absolute value, this is what we do. We restrict the domain of theta to negative pi over 2 to pi over 2. Well, the reason why we do this because we just want to do it. We just want to pick the interval that cosine theta is positive. So we have no problem with absolute value, right? Because if you pick theta in between negative pi over 2 to pi over 2, well, this is going to be the domain that make your cosine positive. So when you let x equal to sine theta, you can say where theta is in between negative pi over 2 to pi over 2. Right? This is because you want your absolute value here to be positive thing. All right, and that cosine gonna cancel. So at the end, you have integrate sine cube theta d theta. and then you integrate this thing, because you know how to integrate this thing, right, from the previous section. If you integrate this, you're going to get the answer in terms of theta, and then you convert back to x. That will be your answer. So many steps, but this is the idea. You change the, you do a substitution first, and then integrate everything in terms of theta. And then once you get your answer, turn it back to x. All right, we're going to integrate sine cube first. All right, let's look at that. Integrate sine cube. Well, for sure, from the previous section, I'm going to try picking this to be, well, let's make it, let's slow down. So I'm going to just pick u equal to cosine theta. Well, you can see if I pick u equal to sine theta, it will not work because I'm going to get du equal to cosine theta d theta, right? And now I can change d theta to du over cosine theta, which I don't like it because sine and cosine, they do not cancel. So I need to pick u equal to cosine. So I'm going to pick u equal to cosine here. This is going to be negative sine theta d theta. All right, and this is going to be du over negative sine theta. All right, this look pretty sweet to me because I say that I can cancel one side. So this is going to be integrate sine square theta du negative. But because I do the substitution, u equal to cosine. So I need everything in terms of cosine. So this is going to be 1 minus cosine square du, which is integrate u square minus 1, right, du. And that is u cube over 3 plus, not plus, minus u plus c. All right, I have this thing, so I turn u back to cosine. Cosine cube over 3 minus cosine theta plus c. Well, this is the answer in terms of theta, right? This is the answer in terms of theta. But when you want to answer the final answer, you have to convert back to x, right? Because you need to convert back to x. Why do you need to convert back to x? Because in the original question, this is your term that you want to find, right? It's going to be integrate x cubed over square root 1 minus x squared. This is your original problem. So you need to answer something in terms of x. So how do you convert back cosine to x, cosine theta to x? Because you pick x equal to sine theta, which means if you draw a right triangle, so sine theta is going to be x over 1. Sine theta, this is the opposite side over the hypotenuse, which means if your right triangle is here, if your theta is here, sine theta, this is x over 1. And that means your adjacent going to be square root 1 minus x squared by Pythagorean theorem, which means your cosine theta going to be square root 1 minus x squared over 1, which is square root 1 minus x squared. And then you can put this thing back, so you can get, hey, I got it, square root 1 minus x squared to the cube power over 3 minus square root 1 minus x squared plus c. And this is actually your final answer. Sounds good? This is how we do the trigonometric substitution. You can see what the hell is this thing. This is so long and so hard, but well, as I told you before, that this is supposed to be the hardest one for final exam, because this topic requires you so many things. So first of all, you need to convert, do a substitution, and then you change everything in terms of x to in terms of theta first. You integrate with respect to theta, and then you convert back to x. So we have a few more examples to show you today. Well, stay with me. stay tuned if you want to practice more. But the content for trigonometric substitution, well, we're gonna just do the same idea. We just do a substitution, integrate trigonometric function, and then convert back to x. All right. Well, I think you need more example for sure. Well, let's do another one. So before looking at another one, let me summarize how we do a trigonometric substitution. So every time when you see a square minus x square, keep in mind you need to pick x equal to a times sine theta. This is your domain. If you see a square plus x square, you're going to pick x equal to a times tan theta. This is your domain. And if you see x square minus a square, you're going to pick x equal to a times sec theta. This is your domain. So technically, you don't have to memorize the domain until you see, if you see your problem, if you start working on the problem and you get stuck with absolute value, that is when you come back and define your domain theta. But if you have a problem that you don't have any problem with absolute value, you can just do a substitution and go ahead. I'm going to summarize again. So you have a square minus x square. Well, the suggestions say that pick x equal to a times sine theta. If you see a square plus x square, the suggestion say that pick x equal to a times tan theta. If you see x square minus a square, the suggestion say that you should pick x equal to a times sec theta. Only 3 things here. Well, the reason why we skip using cosine, cosec, and cot. Well, the answer from the chat. Our friend asked that why don't we just pick cosine, sec, and cot, cosec and cot. I cannot remember, but for some reason, you can the method that you pick sine and cosine, they are equivalent, so you can just memorize only one. That is why if you pick x equal to a times sine theta or x equal to a times cosine theta, so these 2 methods, they are equivalent. So basically, you're gonna get the same answer. So to reduce your the things that you have to memorize, so we're gonna say, hey, let's just memorize only one, x equal to a times sine theta. It is redundant that you just memorize 2 things and you get the same result. That's my understanding. Well, I'm not sure, maybe they have another reason that we avoid cosine theta, a times cosine theta, but well, based on my experience, so I guess, not 100% sure, I guess that x equal to a times sine theta and x equal to a times cosine theta, they are equivalent and they give you the same answer. That's why people avoid cosine theta and just memorize only one. The same technique with tangent and cotangent, secant and cosecant. So we're gonna just memorize this thing. Just keep it minimum as much as possible. All right, so we're gonna do more example, people. So it is not some questions are not that hard. So let's look at that. Example 166. All right, this is the simple one for trigonometric substitution. So let's look at that. So I have 1 equal to 1 over 1 plus x squared to the 3 over 2, right? Well, you can see what I see here. I see a squared plus x squared. Well, that means I have to let x equal to tan theta. And then, well, if I choose x equal to tan theta, I can differentiate this thing with respect to theta. So differentiate tan, I get sec squared. Well, I move the x to that. All right, and now my integration. Hopefully this is easy. All right, integrate 1 over 1 plus x squared is 1 plus tangent square. All right, simple like that. And 3 over 2. And then dx is going to be secant square theta d theta. You can see that the idea is I am trying to change everything in terms of x to in terms of theta, right? Here, 1 plus tangent square is secant. Looks good, right? And then this is secant square theta d theta. So secant square raised to the 3/2. So this is just integrate secant cube theta. And that the top one you have secant square. And you have 1/secant. Super clean here. So you have integrate cosine. Well, that means you have sine theta plus c. You can see you integrate trigonometric integral already. Because you get integrate cosine here, which is easy. So you get sine. Now you can come back and find sine. So here you have x equal to tangent. That means tan theta equal to x over 1. This is opposite, right, over adjacent. So this means if this is your theta, opposite is x, adjacent is 1. So this is going to be square root 1 plus x squared by Pythagorean theorem. Well, sine theta it's going to be what? Opposite over hypotenuse x over square root 1 plus x squared plus c. Done. Simple, right? Well, it looks simple in the solution, but you can see that it's complicated in terms of you have to digest so many ideas and just put everything together and put it in one question. All right, one more. All right, we're gonna do maybe 2 or 3 more, maybe 2 more. I think it's gonna be perfect for the time. So let's stay maybe 20 minutes more, and then we're gonna leave at 4:20. All right, 167. All right. Well, any question in the chat, you can stop me at any time. But well, I beg you 20 more minutes to stay and practice together. Then you can go. So here I have 4 minus x squared here. Well, you can see that every time when I start looking at this type of problem, I'm gonna look at the thing that close to a square minus x square plus a square or something. So I can do a substitution. Here, this is the same thing with 2 square minus x square, right? Well, that means if you compare this with a square minus x square, this suggests x equal to 2 times sine theta. All right, x equal to 2. Sounds good. Now we're gonna pick x equal to 2 times sine theta. You know what? If you don't know how to integrate trigonometric integrals, if you start something like this, if I grade this problem, if you say that, you already get 4 of 10. Man, this is, you shouldn't leave it blank. At least you should know how to do a substitution, and then you just compute more. Dx, this is what? Differentiate x, differentiate sine, you get cosine. All right, it looks good to me. Next, we are going to do a substitution now. X squared over square root 4 minus x squared dx. It's gonna take a while for you to convert everything into theta, but you have no way, and you have no choice. X squared, this is going to be 2 sine square x, 2 sine square theta. Well, that is going to be square root 4 minus that x is 2 sine theta square. And then dx is going to be 2 times cosine theta d theta. Now it's just your turn to simplify. So it's going to be 2 times sine square, right? On the denominator, I have 4 minus 4 sine square. Well, 2 cosine theta d theta. So if you see that, you can group the top one together. So you have 4 sine square cosine. And then on the denominator, I can pull out number 4 here. So I'm going to get 4 times 1 minus sine square. And then I take square root, right? That number 4 here that I circle, gonna cancel with square root 4 here. So you get to integrate. Oops, I missed the theta there. So 2 sine square theta cosine theta over. Well, let's look at that. Square root 1 minus sine square. This is the same thing with square root cosine square. And then now cosine square is what? Cosine square take square root. This is actually absolute cosine square, right? Oh, but we want to cancel that cosine with the top the cosine of the top one. Well, I'm gonna say x is in between pi over 2 and pi over 2. But not x, sorry, theta. Because, well, if I restrict to that domain, this cancel. Because cosine gonna be positive for sure. If you do not fix the domain there, you're gonna have two answers, right? Because the absolute cosine can be positive or negative, depends on the theta. But, well, to avoid that question, so you just well, let me 1 second. I just look at the chat now. I think I did something wrong. Oh, okay. Thank you. Someone to stop me. Here should be 4 on the top one. Good. 4. I did it too fast, people. 8. And 8 cancel that, so you get 4 here, right? All right, sounds good. Now you have 4 integrate sine square theta d theta. All right, almost there. All right, so how do you integrate sine square? All right, so it's come back to 4 times integrate sine square theta d theta. So for sure you need to use identity, right? Because this is sine square. So you have no choice. So you have to use identity. So 1 minus cosine 2 theta over 2 d theta. And then, well, 2 and 4 gonna cancel 1 time. So you get 2 times integrate 1 minus cosine 2 theta d theta. All right, and that is 2 times integrate 1 d theta minus integrate cosine 2 theta d theta. All right, I'm trying to go slow. And next we have 2 times theta minus 1/2 integrate cosine, you get sine, right? Sine 2 theta. So the reason I have 1/2 here because I use the u substitution. So I pick u equal to 2 theta. So I need to have 1/2 here. And then plus c. All right, so I'm gonna move to the next page here, but we're almost there. So we're gonna have integrate x squared over square root 4 minus x squared dx. We came to now we have 2 times theta minus 1/2 sine 2 theta plus c. All right, now we just need to convert everything back in terms of x. That would be fine. All right, what we have, again, we have x equal to 2 times sine theta. So again, that means you have sine theta equal to x over 2. Well, if your theta is here, your opposite is x, your hypotenuse is 2. So this is going to be square root 4 minus x squared. All right, see here I have 2 theta minus sine 2 theta plus c. All right, everyone type in the chat, please. What is going to be your theta here? So let's check if you are. Artiwat say arc sine x over 2. Everyone agree? Arc sine equal to? Yes, right? Everyone agree? Because if you have that, so your theta is just arc sine x over 2. Sounds good. Does it make sense? Okay. That would be good. So 2 times arc sine x over 2. All right. How do you deal with sine 2 theta? Well, sine 2 theta, if you use identity, so it's going to be 2 times sine and cosine, right? And that sine theta is x over 2. Cosine theta is square root 4 minus x squared over 2. Well, that means sine 2 theta, this is x times square root 4 minus x squared over 2 plus c. So here you have to use identity of double angle. You have no choice. Well, you have to, because well, this is how we manipulate sine 2 theta. And that is your answer. Well, I warn you that in the homework, you have to use this double angle identity as well. I think that on the homework, you have one question that we ask you to do substitute trigonometric substitution, and then you're gonna end up with sine 2 theta, and then you have to use double angle. If I am not wrong, well, I checked the homework last week and I saw that question. But yeah, that's the trick that you have to do it. All right. Any questions? Any questions? No. All right. So we can keep going, huh? 4 or 5 now. I think one more question would be good. So I want to show you. Let me see. This is not secant. I want to show you the secant one. Okay, let's do 169 first, and then we're gonna come back to 168 next time because I want to show you how to do the secant because we have not seen the problem on using secant substitution. This one is the one. So we're gonna do this one, and then we're gonna end the lecture today on this question. Are you ready, everyone? All right, all right. So for this question, to make the number look nicer, so let me kill this thing, and let's say this is 3. So the number look nicer when you use 3. All right, let's do it. So we're gonna start by seeing something inside the square root here. So you can see that the thing inside the square root here, you have 4 squared minus 9. This is going to be 2x squared minus 3 squared. All right, if you compare it, this is just a squared. Not a, sorry. 2x squared minus 3 squared, right? 1 second. That means you're gonna have, well, let me write again here. You have x squared minus a squared. You're gonna pick x equal to a times sec theta. Here, you have 2x squared minus 3 squared. So that means you have to pick 2x. Well, we're gonna let 2x equal to 3 times sec theta. Does it make sense? Well, the reasons, the question said that, well, the technique said that if you have x squared minus a squared, so you're gonna pick that x equal to a times sec theta. So here you have 2x squared minus 3 squared. So we're gonna pick 2x equal to 3 times sec theta. That's good. You can memorize that something in terms of x squared minus constant square. You're going to pick that something in terms of x there equal to a times sec theta. So because here we don't have just x, we have 2x. So I'm going to pick 2x equal to 3 times sec theta. So in other words, x equal to 3 over 2 sec theta. well, doesn't matter, the same thing. All right, so we're gonna have dx equal to 3 over 2 sec theta tan theta d theta. All right, so first of all, we are going to integrate first, and then we're gonna plug in the upper bound, lower bound at the end. So we're gonna integrate 4x squared minus 9 over x dx. Here we're gonna integrate. All right, it's going to be a little bit tough here. X equal to 3 over 2 sec theta square minus 9 over x, which is 3 over 2 sec theta. All right, and then I already changed the x to d theta here, 3 over 2 sec theta tan theta d theta. All right, I change everything in terms of theta. You can see that the big term on the right hand side, but something cancel. 3 over 2 go. Secant away, go away. Secant theta go away. So what we have left? Integrate. All right. Square root 9 square sec square. Right. Minus 9. Because this 4 cancel out and 2 square. And then I have tan theta d theta. All right, this is the same thing with integrate. That is not 9 square, sorry, just 9. All right, and then I can pull out number 9 and then take out all from square root, so you get 3. Square root sec square minus 1. What is going to be my secant square? Minus 1. For sure, this is tangent square. And then take absolute. Right, but well, let's start by saying square root tan square first. All right, I'm gonna carry this thing to the next page. Integrate 4x squared minus 9 square root x dx. So after I do substitution, so now we end up with 3 times integrate absolute tan theta d theta. Now, how do I know that? I'm gonna use, well, what should I do next? Because I have absolute value here. All right, I have absolute value here. What should I do next? So you can see that what we need is, so for the previous question, I say that because we're gonna avoid the ambiguous number because of absolute value. So we're gonna pick the domain of theta. But for this question, you already know that x is going to be 3 over 2 to 3. So here 3 over 2 to 3. So can we see that x is equal to, well, let's think like that. X is in between 3 over 2 to 3. What does it mean? It means 3 over 2 gonna be 3 over 2 sec theta. This is your x, right? It's gonna be between 3 and 3 over 2, which means your sec theta, it's going between 1 and 2, right? Well, when sec theta is between 1 and 2, your theta are going to be between 0 to pi over 3, right? Because sec theta is 1, that means theta equal to 0. Sec theta equal to 2, that means theta is pi over 3. So you have theta is in between 0 and pi over 3. If your theta is in between 0 and pi over 3, your tan theta are going to be positive all the way, right? This is going to be positive because, well, you are forced to use theta in between 0 to pi over 3 at the end. So we're going to have 3 integrate tan square. Well, no minus sign here. Well, also tan square you can integrate by switching to secant square minus 1, right? We just discussed on the first 10 minutes. And this is going to be integrate secant square d theta minus 3 times integrate 1 d theta. well, which is going to be 3 times integrate secant square, so you get 10. And then minus 3 times theta plus c. All right. Because you already say that x is in between 3/2 to 3. Well, that means theta is from 0 to pi/3. So this is going to be 0 to pi/3, 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 right? And this is going to be from 0 to pi/3. All right, you plug in that, so you're going to get 3 times 10 pi/3 minus 3 times pi/3, right? And then minus 3 times 10, 0, minus 3 times 0, which is going to be 3 times square root 3 minus 3. All right, everything else 0. Oh, minus pi, sorry, minus pi. All right, this will be your final answer. Is it fun? Not at all, huh? So, well, at the end, your answer is going to be 3 square root 3 minus pi. All right. Well, I think we're going to end the chapter here. For the practice problem here, I'm going to show you in the clip. Well, stay tuned for the clip in my channel. And also the example that I skipped here, I'm going to show you. I'm going to show the solution on the practice problem clip anyway. Practice problems clip. So this one I'm not going to show you in class. So let's watch the practice problem after class. All right. That's just the end of this chapter. So any questions, people?